This is College Algebra, Chapter 1, Section 1, Linear Functions, Equations, and Inequalities. Okay, first let's look at the sets that make up the real numbers, and you've seen this before in your previous algebra classes. The very basic numbers that we have are the natural numbers, that's 1, 2, 3, 4, and so on. When you put a 0 in front of that, then you have what are called the whole numbers. So the natural numbers are a subset, or a smaller set from the whole numbers. Then when you add in the negatives, you have the integers. So natural numbers, whole numbers, and then the integers. The whole numbers are inside of the integers. And then we have the rational numbers that encompass all of these. Any number that can be written as a fraction is a rational number. So for example, 4 is a rational number. You can write it as 4 over 1 or 8 over 2. So the natural numbers, whole numbers, integers, all of those are inside of the rational numbers, and then we add in numbers like 1/2 and 3/4. And then we also have, as part of the real number system, irrational numbers. Irrational numbers are numbers that cannot be expressed as a fraction. For example, pi is an irrational number. The square root of 2 is an irrational number. Really, the square root of anything that doesn't come out even is going to be irrational. So the rational numbers with all the subsets that go into that, plus the irrational numbers together form the real number system. Okay, in this example, you need to tell which set of numbers each of these numbers belongs to. So pause the recording, see if you can figure it out, and resume the recording to check your answer. 0.6 repeating is 2/3. It is rational. A repeating decimal is a rational number. 0.25 is 1/4. That's a terminating decimal, and it too is a rational number. And then pi. Well, I mentioned pi before. Pi is irrational. It is a non-repeating and non-terminating decimal. Now when we take the rationals and we join them with the irrationals, like we said, we have the real number system. That U in between the word rationals and irrationals is a symbol for union. In other words, we're putting the two things together. We have what's called the number line, and every real number corresponds to a point on this number line. Okay, that gives us the coordinate system. The number corresponding to a point on the number line is called the coordinate of that point. The correspondence is called a coordinate system. And incidentally, 0 is called the origin. Now when we take two number lines and we have them meet at right angles, like you see here, we have what's called the coordinate plane. It's also called the Cartesian coordinate system. This is named after René Descartes, who was a French mathematician. It's also called the XY plane, or the coordinate plane. It can also be called the rectangular coordinate system. So a lot of different names for this one idea. Note that the points on the XY axis do not belong to any coordinate. If you remember how this is set up, the x-axis is horizontal, the y-axis is vertical. It splits the plane into 4 quadrants. You see them numbered there. Points will belong either on an axis or in one of the quadrants. If they're on an axis, they're not considered to be in any quadrant. And for any point AB, A is the x-coordinate and B is the y-coordinate. By the way, 0, where the two lines meet, is still called the origin. When we use our graphing calculator to graph equations, it's really important to pay attention to our viewing window. If you'll notice, we've got two viewing windows here. Both of them, the x values go from -60 to 60, and the y's values from -40 to 40. If you look below them, you've got x min, -60, x max 60. That means minimum and maximum x values. Y minimum, -40, y maximum 40. And the scale on the one on the left, it says x SCL, that's x scale, and y SCL is y scale. It's set at 1, which means that normally you see little marks as you go along the graph. Well, there's only a distance of 1 between every one of those marks. And because we have, well, 120 numbers that are being covered horizontally and 80 vertically, all of those marks are smushing up next to each other and just making the lines look thicker, and you can't see them. If you look at the second graph, what they've done here, the x minimum and maximum and the y minimum and maximum have not changed. What has changed is the scale. It's gone from 1 to 10 in both cases. And what you'll notice is you can now see those little tick marks, and each of them represents 10. So if you start in the middle at 0 and you count, you will notice that from 0 to the right end, there are 6 of them. That's 10, 20, 30, 40, 50, 60. And from 0 to the top or the bottom, you've got 4 of them, 10, 20, 30, 40. So when you are graphing, adjusting that scale can really be a benefit to you and make the graph look a little better. Let's talk some more about the viewing window. If you hit the window button when you're graphing, this is what you'll see. This is actually a standard window. If you zoom standard, this is what it's going to give you. Just a little review of what these things mean. X min means the minimum x value. X max is the maximum. And x scale is the distance between the tick marks on the axis. For the y's, it's the same thing. Y min is the minimum y value. Y max is the maximum y value. And y scale is the distance between the tick marks on the y-axis. Now, something you're going to notice is we have a notation for our window setting, and it looks like this. You're going to use brackets, and the first bracket is going to contain the x min and the x max with a comma in between. The second set of brackets contains the y minimum and the y maximum with a comma in between, and in between those two sets of brackets is the word by. So this window right here would be noted by what you see there at the bottom. You have negative 10, comma 10 in brackets, by, and then again brackets with negative 10, comma 10. Okay, rounding numbers. You've done this before. It's just an example. Got some numbers in this chart on the far left, and then you see them rounded to the nearest tenth, the nearest hundredth, and the nearest thousandth. Remember, the general rule is that you look at the number to the right of the place you're rounding to. If that number is 5 or above, then you're going to round up, and if it's 4 or below, you're going to leave it the same. You can also round, or tell your calculator to round for you. If you go to the mode on your calculator, hit the mode button, the second item there says float, and then it has the numbers 0 through 9. Float means that the decimal point will be wherever the decimal point is, and it won't do any rounding except for the limitations of what the screen can display. The numbers 0 through 9 indicate where the calculator will round to. So if you're doing problems and you always want it rounded to a particular place, then you highlight that number and it will round there for you. The 0 will round to the 1's place, and so forth. Okay, our calculators also have the ability to express numbers like these. These are irrational numbers. We've practiced these before in algebra class. First, we have the cube root of 87. If you go to the math menu, you actually do have a symbol for cube root. Punch that and then put in 87, hit enter. Likewise, if you remember from algebra, a root can be expressed as a fractional power. So in other words, a cube root is the same as a 1/3 power. So on the screen you also notice they put 87 to the 1/3 power. Notice that the power is in parentheses, and you get the same answer. Same for the 4th root of 12. Now your calculator does not have a 4th root symbol. What you do instead is you put the number 4 in, go to the math menu and choose the root with the little x out front, and then put in the 12. Or you can do 12 to the 1/4 power. There are other special keys in your calculator. Those that are listed there are actually on the face of your calculator. And by now, you should be pretty familiar with most of them. All right, the Pythagorean Theorem. Now, I know you're thinking, well, this is not geometry. Why are we looking at the Pythagorean Theorem? Well, we're going to be going somewhere with this, so just a little review. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In other words, for that triangle, a squared plus b squared equals c squared. We actually use this to get our distance formula. When we have 2 points, like the points P and R, you can draw a line between them. If you want to find that distance, you can make a triangle from these 2 points. What we're going to do is from point P, we're going to draw a line straight down. From point R, we're going to draw a line across to the left, and they meet at point Q. And they form the 2 legs of our right triangle. Notice what the diagram is showing you. The length of the vertical leg is y2 minus y1. It's the difference between the y values. The length of the horizontal leg is x2 minus x1. It's the difference of the x values. So the hypotenuse is going to be that x2 minus x1 squared plus y2 minus y1 squared, and then you're going to take the square root of that. This is in a formal statement. This again should not be anything new. We've done the distance formula many times before in math class. And we're going to do an example using the distance formula. We're going to find the length of the line segment that joins the points P and Q for those given values. Pause the recording, give this problem a try, and resume the recording to check your answer. Okay, first we put the numbers into the formula. And then simplifying, we have 11 squared plus negative 6 squared. And we have the square root of 157. Please remember that in all calculations, even when you use your calculator, you should be showing the setup as part of your work. Next, we have the midpoint formula. Midpoint is the point in the middle of the line. And you kind of find it just like you'd find a number that's in the middle of 2 other numbers. What you do is you add them together and you divide by 2. And that's what we're going to do here. You're going to add the x values together and divide by 2. And you're going to add the y values together and divide by 2. Remember, this is a midpoint, and your answer should be a point. It should have an x value and a y value. Let's try this example. You're going to find the midpoint of the segment with endpoints 8, negative 4, and negative 9, 6. Pause the recording, attempt the problem, and then resume the recording to check your answer. Here's our formula, putting the numbers in, and finally we get that our midpoint is negative 1/2, 1. Try another example. 4 quarters after the launch of the iPad, about 19.5 million were sold. After 10 quarters, about 99 million were sold. Use the midpoint formula to estimate how many were sold 7 quarters after launch, and then compare that with the actual value. Pause the recording, try the problem, and resume the recording to check your answer. Okay, so 7 is halfway between 4 and 10. So we're going to find the midpoint joining the points 4, 19.5, and 10, 99. And we find that in quarter 7, according to the midpoint formula, 59.25, 59,250,000. It's pretty close to 50 million. All right, these are some problems to try to make sure you understand the concepts we've been talking about. You need to try the problems, pause the recording while you're doing that, and then resume the recording to check your answers. Again, pause the recording to attempt the problem, resume the recording to check your answer. Pause the recording, resume the recording to check your answer. Pause the recording to try the problem and resume to check your answer.